Hello everyone, I welcome you all. In this video, I am going to solve question number 1 which appeared in GATE 2020. The question is, which one of the following is the solution of the differential equation d square u by dx square is equal to k square of u times u of x? And there are 4 options. First option is e to the power minus kx, second option is sine kx, third option is cos of kx, and fourth option is sine hyperbolic x. So before solving the question, I would like to give a brief introduction. What is differential equation? So any equation which consists of any function and its derivatives is called differential equation. So here the function is u of x and d square by dx square is its derivative of the function. So this is a differential equation, and this is basically a second order differential equation. So the general form of any second order differential equation is like this. Excuse me. Yeah. D square y by dx square plus p of x dy by dx plus q of x y is equal to fx. So this is general form of any second order differential equation, and in our case this is the second order differential equation, homogeneous differential equation with constant coefficient. That is, if we don't have any fx over here, so fx is 0, and also the coefficients, that is px, or we don't have this term in this differential equation, but we have d square u of x dx square is minus k square. Okay, so we don't have RHS, so RHS is 0, and also we don't have this first derivative of y, so that term is also missing. So we only left with two terms, this term and this term. Moreover, q of x here is k square and it is constant, it is not a function of x. So all these kind of equations is called second order homogeneous differential equation with constant coefficients. If we had some constant term over here, for example, suppose some 2x or x, then it would not be homogeneous, it would have been a non-homogeneous equation. But here we have 0, so it is a homogeneous differential equation of second order because they are two time derivatives. Okay, now in order to solve this question, I will just write it again. D square u of x dx square minus k square mu of x is equal to 0. Let us assume that we have a solution. This is general approach to solve any second order differential equation. U is equal to e to the power some r time of x. Let us assume that this is the solution of this question, of this equation. Okay, in that case you just do double derivative of this. Du by dx will be nothing but dy by dx should be r e to the power rx, and d square of ux by dx square will become d of dx r e to the power rx, which will become r square e to the power rx. Okay, Now we substitute this back into this equation. So what we will get is r square e to the power rx minus k square e to the power rx is equal to 0. We can take e to the power rx as constant, and we're left with r square minus k square is equal to 0. Now, since e to the power x cannot be equal to 0, so we are left with r square minus k square is equal to 0. This is called auxiliary or sometimes characteristic equation. So now we'll just solve this characteristic equation. The solution will be r square is equal to k square. Therefore, r is equal to plus minus k. So we got two roots of this auxiliary equation, and that is plus minus k. And since these roots are real and distinct, therefore the solution of this kind of differential equation is just some constant c1 times e to the power kx plus some constant c2 e to the power minus, because second root is minus k, so minus k of x. So this is the solution of this equation, and in the question they have asked which one of the following is the solution of x. So we can see that in option A, e to the power minus kx term is present, so which is a possible solution of this differential equation. Okay, so the answer for this question is first option, e to the power minus kx will be the solution. And they've also given fourth option, sine of hyperbolic x, which is not the solution. But if they have given, suppose, sine of hyperbolic kx, then that could also have been the solution, because we know the sine hyperbolics of kx could be written as e to the power kx plus e to the power minus kx by 2. But here they have just tried to confuse you. So all these options are wrong, only A is correct. Now there is another trick through which you can solve this question in short time, because you are appearing competitive exam. So you just substitute this e to the power minus kx into the original equation. So original equation is d square ux by dx square is equal to k square. So you just substitute e to the power minus kx. So d by dx of e to the power minus kx will give minus k e to the power minus kx. And again, when you substitute this to get the LHS of above equation, at k square e to the power minus kx is equal to, so this satisfies the original equation. So e to the power minus kx satisfies the original equation. Hence, in this way, option A is correct. Thank you for watching this video.